So this linear equation stuff, like these points right here, it's really kind of checking our work back when we were solving equation stuff. So for example, we want to determine if these points are solutions to the equation. What that means is that if I were to graph this equation, then this point has to be on the graph, right? So if we look at this graph, this isn't the graph for this one, but let's say that this is the line right there, right? Well, if 0, 9 is right here, you see how it's not on the line? Right there, the purple point, it's not on the red line. So it wouldn't make a solution for the equation, okay? So here's what we're going to do. We're going to replace the x and y with their respective values. For example, x here is 0, and the y is 9. And then we just see if this is true with the rest of the stuff. Well, 0 plus 9 is 9. And 9 does equal 9, that's true. So yes, this is a solution. Four here is a little tricky because they give us a y value there, right? This y value 5. But where am I replacing that 5? Well, there's no y in that equation. So really all I can do is replace the x and see if that's true. So I'm going to replace the x with the negative 6 that I have and see if this equals negative 6. Well, that's already true. So this one also is a solution. So once again, I'm going to replace the x with 2 and the y with 1. And we'll see if this is a true statement. 4 times 2 is 8, and 3 times 1 is 3. So 8 minus 3 equals, it's not 3, it's a 6. 8 minus 3 is 5. Well, 5 does not equal 6. So yeah, we'd say not a solution. For each of the given equations, complete the ordered pairs beneath it. So here, for A, we have an x value that's 2. So really, this ends up being y equals x, which is 2. And then we'll add the 3. Well, 2 plus 3 is 5. So the ordered pair is 2, 5. And then I would put that on a graph if it had asked us to graph that, which it will on the next part. For B, now the x is 0, so I have y equals 0 plus 3, which is just 3. So that gives me this ordered pair, 0, 3. Now C is a little bit different though, because now it gives us a y value. So I have 3 equals x plus 3. And you may ask yourself, what plus 3 is 3? And hopefully we would see 0, but we can use principles of equality to solve that too. By subtracting 3 from both sides, we see that x is 0 as well. Oh, I guess I should have noticed that. The b value here, the y value is the same as that c value, y. The y value in c. Well, that was a little tricky of them, but let's do D. So now we'll replace y with negative 7, which should equal x plus 3. And again, to solve this, I would subtract 3 from both sides. And I got x equals negative 10. So negative 10, negative 7. And then finally E, where the y value is 9. So I've got 9 equals x plus 3, and subtracting 3 from both sides, x equals 6. And there's all our ordered pairs there. So number 4 was kind of like this one, where it just says x is negative 2, right? Now notice, we're only replacing the x values in this. Excuse me. And that's because x is negative 2. So when y is negative 2, x is negative 2. When y is 0, x is negative 2. X is just negative 2 all the way through. It would not matter what value they put for the y value there. X is just always going to be negative 2. 10 here is the same idea. It's just that now y is 3 instead of x being some value. And since there is no x in this, it doesn't matter what x is, y is just always going to be 3. So we'll replace all the y values with 3. Bam. Alright, for number 8, here the first value is an x. So y will equal 2 times the x, which is 2, and then minus 5. So that gives us 4 minus 5, which is negative 1. So when x is 2, y is negative 1. And the next one, x is 0, so y equals 2 times 0 minus 5, which is the same as 0 minus 5, which is negative 5. There's that one. Now c gives us a y value again, so we have 3 equals 2x minus 5. So we'll subtract 5 from both sides to get the x's by themselves. And I got negative 2 equals 2x. And then dividing both sides by 2.
What would be adding 5?
Did I write that down wrong? I did. I apologize. Yeah, so that's going to change a little bit there. Yeah, so that was minus 5. I apologize. Just completely wrote that down wrong. Let's add 5 to both sides. So that now that's 8. And we'll divide by 2 to make that a 1x. And x is 4 now. That's better. Thank you. And then this next one, the y is negative 7. And that should equal 2 times the x, which we don't know. And I'll put minus 5 this time, the correct value. So let's go ahead and add 5 to both sides on this one. And that gives me negative 2 equals 2x. Then dividing both sides by 2, x is negative 1. There we go. And then finally, y is 9. So 9 equals 2x minus 5. Add 5 to both sides. And we got 2x equals 14. So dividing by 2, x is 7. And there's all our ordered pairs for that one. So it says we need 3 or more ordered pairs, which is good. And it says to use a t-table, which we will use. All that means is that we get to choose values to put into the table. So it's kind of like the tables it's kind of like the ordered pairs we just saw, but now in a table. So here's what this is this is a t-table, and we put the x values on the left so that they just look like ordered pairs, and the y values on the right. Now here's the thing though, is it's really easy usually to use x is 0. Sometimes we can use y is 0, but it's not always necessarily the case. So I like to choose just values of x on this, and I'll make it negative 1 and 1. Now if you don't like working with negatives, you don't have to use negative 1. You could use 2 unless it took you off the graph, then you may have to use a different value. And we'll look at these. So this first one, the x is negative 1, so I got negative 1 plus y equals 3. And to solve this, I would add 1 to both sides. And I got y equals 4. So that's this ordered pair, negative 1, 4. That is an ordered pair. We don't have to show it like that, but I need you guys to see it. So that gives me this point, negative 1, 4. This point. Now the next value is a little bit easier to work with because x is 0. So on this one, we got 0 plus y equals 3. And there's not really any reason to put plus 0 on anything. So we just have y equals 3. And again, this is an ordered pair. So at 0, 3, I would have this point right here. On this next one, x is 1, so I got 1 plus y equals 3, so subtracting 1 from both sides. y is 2. And again, this is an ordered pair, so 1, 2. We can kind of see the pattern of what's happening right here, right? If we continue this pattern, we may look at these points right here. Not that it's completely necessary for us, but it shows a straight line, and that's what linear means, that we have a straight line when we graph. So all I need to do now is connect the points. Something like that. So again, for this one, we're going to make a table. We got an XY table. You can call it a T table if you want. If it helps to box those in, that's fine as well. Okay. Now, this is the best part about this. We get to choose the values of X we want to use. You can choose values of Y if you want. The choice is yours. It just depends on how you want to solve the equation. So what do you want me to choose, X or Y values? Again, just keep in mind it's not really going to matter which one we choose.
Y.
Let's choose Y. Alright, so it's always helpful to choose a 0 value. Now to see the pattern, it may help to see a negative value and then a positive value, and 1 is also easy to work with. Most of the time, okay? So on this one, so when Y is -1, I just need to figure out what X is, right? So in the equation, I've got X minus the Y value, which is -1, and that should equal 2, right? Well, minus that negative really becomes a +1, and that I think goes back to module 1. If we subtract 1 from both sides, then we get X equals 1. So that gives me this point, 1, -1. So I would take 1, -1, and that gives me this point. So we'll change that Y to 3. So on this one, I've got X minus, and I'll just show this full equation like this, right? X minus Y equals 2. But right here we're saying that Y is 3. So I'm replacing Y with 3. So something minus 3 equals 2. And to solve that, I would add 3 to both sides, just like we did with the equation stuff, right? And X equals 5 in this case. So that gives us a point 5, and then up 3. So that's another point on this graph. So we can already see the pattern. If we were to connect these 2 points, we'd get a line somewhere in this area, okay? Now, we still need a third point because it told us that we needed the third one. So let's find one. Yeah, let's do that. So we'll say that Y is 5 in this case. So again, we'll come back to the equation, which is X minus Y equals 2, but we're replacing Y now with the new value of Y that we chose, which is 5. Well, something minus 5 is 2. We can solve that by adding 5 to both sides, unfortunately. That gives us X is 7. So 7, 5, that's a little bit off the chart up here, right? I mean, it would be maybe somewhere in this area. Now, it does go along with the pattern. Unfortunately, though, it's just not on the graph. So we should choose another value on this. And that's okay. I mean, 5 was okay. But, well, what value do you guys want? I'll point this out, okay? So we got this point here at 1, -1, and then 5, 3. If we just choose an X value between those two, then we should just be able to connect those, okay? So I would say let's let Y equal, I don't know, 1. Let's see what that looks like. Well, let's do 2 because we did 1 on the last one. So again, we're just going to come back to the same equation. So that's X minus Y equals 2. And we're replacing Y now with 2. Notice it does not affect the minus there. So to solve this, I would add 2 to both sides. And I got x equals 4. So that's 4, 2, which would be this point. And we can kind of see if we were to connect these. And it has a pretty nice slant to it. Like this. And yeah, eventually it would get up to that point 7, 5.
Okay, so the point.
So the purpose of the third point is just to confirm that we've got that correct. Because if by chance we had graphed that red point and it was over here, well, you see it's got a curve now just to connect the points there. That's not what we want. So we would know that it's incorrect if it does not make a straight line. Now eventually, in some of the other classes, you'll get into non-straight lines. But for now, this is all we got for now. And again, for this one, we want to make a table, right? So then we get to just choose the values. Now for this one though, since we have y equals 3x minus 2, it will be easier for us to choose x because if we just plug x into that equation there, we'll have solved for y after we do some operations. So choosing values of x, again, they should be values that run along this this line here. So, I mean, if we choose the middle value, hopefully that's on there, right? And that is x is 0. So if x is 0, then y equals 3 times 0 minus 2. Well, that would just give us 0 minus 2, which is negative 2. So when x is 0, y is negative 2. And then we can plot that point. X is 0, y is 2, negative 2 rather. So there's our first point. Okay, so let's move maybe 1 to the right of that. So let's choose 1. So again, we go back into the equation. Y equals 3. Now x is 1, and then minus 2. So y equals 3 minus 2, which is 1. So we have x is 1, y is 1, and there's our next point. Now we only need one other point on this because we only need 3 points. So maybe we just move 1 more to the right, 2, and see if that works. So y equals 3 times 2 minus 2. So y equals 6 minus 2, and y equals 4. So we have this point 2, 4 right here. And again, that should show the pattern, some kind of staircase like this. Not that that's completely important, but it will be someday. Okay. Well, all we got to do now is draw the line. So let's see. Yeah, something like that. That'll work. We did see examples like this on that first part of this section. But for this one, we don't really get to choose values of y. Why? Because y is 3. That's what the equation is telling us. Y equals 3. So choose any values of x that you want. Negative 3, negative 1, 0, 2, and 4 maybe. So if x is these values, then what is the y? Well, y is 3. So we're just going to put a 3 all the way through. Because y is 3. That's it. So we can put these points on here. Negative 3, 3. Negative 1, 3. 0, 3. 2, 3, and 4, 3. And we can see that's forming a line horizontally Yeah, about right there. That's a little bit better. And that would be it. Same idea, but now it tells us what x is instead of y. So when we make our table, we need to choose values of y because x, and we could start with the x if we wanted to. We can just make x -5 all the way through, and then we can choose values of y. And we could have done this on the last one. It really is up to you. So we could say x is -5, y is, I don't know, -5, -1, 2, 3, and 4 maybe, something like that. So that gives us these points. X is -5, -5, -5, -1, -5, 2, 3, and 4. So we have this line now. There we go. On this one specifically, when we look at values of x, what I'm probably going to want to do is choose values that are multiples of 2, or even numbers. The reason that is because,
you need to be able to cut it in half.
yeah, exactly. And if we do cut it in half, we want a whole value to work with. If we use odd numbers, then we're going to continue to keep fractions in this thing, which will be a little bit difficult, especially on the homework since it's on the computer. We need a whole value. So we need to choose even numbers. Like, I mean, we can look at -2. 0 is fine, even though it's not necessarily even. And then 2, maybe. I mean, yeah, if you want to use 4, that's fine. We don't want to go up to 6 because it's not on the graph. So let's take a look at these. So on this one, the first one, we got y equals -1/2. This is going to be times this -2 plus 4. So in the calculator, I can do this. -1/2 times -2 is 1 plus 4, which gives us 5. So when x is -2, y is 5. So there's our first point. Now, when x is 0, we got y equals -1/2 times that 0 plus 4. So y equals 0 plus 4. Anything times 0 is 0. So y is 4. So we have this point 0, 4. And then just one more point should do it. We can do the 4 one though. -1/2 times 2 plus 4. So y equals -1/2 times the 2 is -1 plus 4. So y is 3 there. So I got the point 2, 3. And again, we can't do that 4 point just to make sure. So I'm going to do the 4 value as well, just in case. So we got y equals -1/2 times the 4 plus 4. And again, if you're struggling with the multiplication here, just use a calculator. -1/2 times 4, -2 plus 4. So y equals 2. So when x is 4, y is 2. I got 4 and 2. And that gives us the line. Now I can draw this one. Not a big deal. There we go. Alright, so let's start with 13. And we will make a table. We only need 3 values on this thing. Now it did tell us y is -2, so let's just put those in there right now. We just get to choose the values of x. So maybe you want x to be -3 or 0 or 5. I don't know. It's really up to you. So let's put these points on then. So I got -3, -2, 0, -2, and then 5, -2. So that gives us this line, like this. And then this one here, x and y, but this one tells us x is 3, so let's replace the x values with 3, because x is just going to be 3 no matter what. And now again we get to choose values of y, so whatever you want there, -4, 1, 3 maybe, I don't know. And so we got 3 -4, 3 1, and 3 3. So that gives us, well, a little off there, but that looks better. So we can see just from these two examples, just like the last two that we did, like these two, when we get y equals something, it's a horizontal line, like the green line. And then when we get x equals something, it's a vertical line, like the black one.